talk about indefinite integrals as opposed to definite integrals, which is what we covered last week. So indefinite integral, the only difference is that there are no bounds. So instead of saying I want to find the integral, the area under the curve for, let's say, x squared. So I want to find the area under the integral from x squared dx. Indefinite integrals just don't have the bounds. So then you can find it at any point. Yeah, and that's the only difference. So we're going to talk about the fundamental theorem of calculus, part 2, using it to analyze graphs, and then finding just indefinite integrals and using antiderivatives to evaluate those. So for this, I'm just going to give you some background and talk about the fundamental theorem of calculus, part 2. So here's some background, just kind of some history about integrals and derivatives. But the gist of it is that differentiation and integration are inverses of each other. For example, if you take the derivative of the integral of something, you're left with just that something. It's like if you multiply by 2 and then divide by 2, you're left with what your original thing was. This is the same idea. Integration and differentiation are inverses of each other. And that's exactly what this theorem says. It says, right here, it says if you take the derivative of an integral from some constant to x of a function, you're just left with that function of x. So, for example, this also says if it's continuous, a continuous function, that means like you can draw it on a piece of paper without picking up your pencil. That every continuous function has an antiderivative. So that's pretty cool too. So, for example, using this part 2, the derivative of the integral from negative pi to x, cosine of t dt, is going to be cosine of x. Because we're taking the derivative of the integral of something. And we can prove it using the fundamental theorem of calculus from last week. So let's first just find the integral negative pi to x of cosine of t dt. So the integral of cosine is sine. So sine of t, evaluate from negative pi, as this straight line means evaluate to x, and that equals, let's see, plug in x, so sine of x minus sine of negative pi. You can use your calculator, or if you're in trig, you might know this, sine of negative pi is 0. So this is really saying sine of x minus 0, which is just sine of x. So remember, that's the integral part. Now we need to take the derivative of it. So what is dx of sine of x? You guessed it. You got it. Cosine of x. Which this literally just says derivatives and integrals are inverses of each other. So this part B, you can do this process on your own to make sure that your fundamental theorem of calculus is good to go. But I can tell you that you will end up with 1 over 1 plus x squared for this one. And that's really the gist of this theorem here, is that derivatives and integrals are inverses of each other. So I'll have other videos talking about how to use this to analyze graphs, and then my last video will be about just finding or evaluating indefinite integrals.